Good afternoon, students. Today we start with the topic equilibrium of a particle. Of a particle or of an object. When we say that an object is at equilibrium, or so other meaning of the equilibrium is stable. When we say that the object is at stable or object is at equilibrium, right? So if we consider one object having some mass, right? So when we say that this object is at equilibrium, so the net force acting on that object, that is external force which we are applying on the object, so that net force is equals to 0. When the applied force on any object is equals to 0, then the object is at equilibrium. Either the object is at rest or it may be moving with an uniform motion, right? So that type of objects we call as the stable object, or we call that one as equilibrium. So that condition is net applied force on any object or a particle that must be equals to 0, right? So the object may be is at rest. So object ಏನಿರಬಹುದು ನಮಗೆ ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇರಬಹುದು, or in uniform motion. So uniform motion ಅಲ್ಲಿ ಇದ್ರೂ ಕೂಡ ನಾವೇನಂತ ಕರಿತೀವಿ, object is at equilibrium. So rest ಅಲ್ಲಿ ಇರೋದು ಕೂಡ equilibrium ಅಂತ ಕರಿತೀವಿ when the net applied force on an object is 0. So the net applied force means the total forces which is acting on the object, that must is always equals to 0, right? So now ಯಾವುದಾದ್ರು ಒಂದು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಆ net means total forces which is acting on this object, that must be equals to 0. Then that case the object may be at rest or the object may be in uniform motion. So that we call as equilibrium of a particle or equilibrium of an object, right? So considering, in discussing, we are in cases, right? So considering two forces which is acting on an object or acting on a particle, right? So the condition for equilibrium of that object when we are applying the two forces. So now two forces apply ಮಾಡ್ತಾ ಇದೀವಿ ಈ object ಮೇಲೆ, right? So we need to write the condition for that this object must be equilibrium, right? So assume I am applying some force F1 that is of some 5 Newton, right? So in the same way I am applying the another force F2 that is of some 6 Newton. Again force is a vector. So nami gotirbeku force is a vector. Vector means it has both the magnitude and direction. So eradu force same direction alli idre this object enagutte nಮಗೆ move ಆಗ್ತಿದೆ. So move ಆಗ್ತಿದೆ, that means the net force acting on an object eradu same direction ಇದೆ. So the resultant force should be is in the same direction, right? The net force acting on the object is 5 plus 6, that is 11 Newton. So this 11 Newton is not equals to 0. That means the object is not in equilibrium, right? So now ಎರಡು forces na consider ಮಾಡಿದೀವಿ. First case ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, ಎರಡು forces same direction ಅಲ್ಲಿ apply ಮಾಡಿದ್ರೆ again from the vectors ಅಲ್ಲಿ we have the formula resultant force R that is equals to square root of a square plus b square plus 2ab cos theta to find the resultant of any two forces, any two vectors. So ಇಲ್ಲಿ ಎರಡು vectors ಇದೆ, both are acting parallel, that means theta value is 0 degree. So cos theta is 1, so this becomes a plus b. So resultant is equals to a plus b, that means directly we can add 6 plus 5. So that means we are getting this value as some 11 Newton. So this is not equals to 0. So the object equilibrium ಅಲ್ಲಿ ಇರಬೇಕು ಅಂದ್ರೆ ನಮಗೆ ಕಂಡೀಷನ್ ಏನು ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಬೇಕು, ನಾವು ಅಪ್ಲೈ ಮಾಡ್ತಿರೋ ಫೋರ್ಸ್ ಯಾವುದಕ್ಕೆ ಈಕ್ವಲ್ ಆಗಿರಬೇಕು, 0 ಗೆ, right? So this is not the way we are applying the forces on the object to keep this object in the equilibrium, right? So in the first case. Next the second case ಅಲ್ಲಿ one force is acting along horizontal, right? So that is some 5 Newton, and in the second case I am applying some force vertical right? So that is some, again we take on some 6 Newton. So 5 Newton is acting along horizontal and 6 Newton is acting along vertical, right? So here also these two are the vectors. Then the angle between these two vectors is 90 degrees. So one horizontal act ಆಗ್ತಿದೆ, ಇನ್ನೊಂದು vertical act ಆಗ್ತಿದೆ. That means the angle between the two vectors is 90 degrees. So cos 90 is what? 0. So cos 90 is 0. So this whole terms becomes 0. Then resulting r is equals to under square root of a square plus b square, right? So that is equals to under square root of 5 square plus 6 square, right? That is some 25 plus 36, that is equals to 61. Again, which is not equals to 0, right? So on the horizontal force, in the vertical force, either in the topward direction or in the bottomward direction. So ಯಾವ direction ಅಲ್ಲಿ apply ಮಾಡಿದ್ರೆ angle between the two forces ಎಷ್ಟಿರುತ್ತೆ 19 ಆಗಿರುತ್ತೆ. So resultant force ಏನಾಗಿರುತ್ತೆ ನಮಗೆ, some value we are getting, that value is not equals to 0. That means the object is not in equilibrium, right? So ನಮಗೆ equilibrium ಅಲ್ಲಿ ಇರಬೇಕಂದ್ರೆ ಏನಾಗಬೇಕು, that value must be equals to 0. So ಈ ಎರಡು ಕೇಸ್ ಅಲ್ಲಿ ನಮಗೆ ಏನಾಗ್ತಿಲ್ಲ, 0 ಬರ್ತಾ ಇಲ್ಲ. So same direction in the one is vertical and one is horizontal. So the last remaining case is same. I am applying the force F1 taken some 5 Newton, right? So vertical I again horizontal in the opposite direction, right? So here it is F2, that is 6 Newton. So same example na 3 cases I will study madra. One, I am pushing the object applying 5 Newton along the positive x-axis and I am pushing 6 Newton along the negative x-axis. Again, these two are the forces, these two having the direction but opposite directionally act ಆಗ್ತಿದೆ, right? So opposite directional act ಆಗ್ತಿದೆ ಅಂದ್ರೆ the angle theta is how much? 180 degree. That is anti-parallel vectors, right? So cos 180 is minus 1. So this becomes r is equals to square root of a minus b whole square, that is equals to a minus b. So here a is, that is 5 Newton minus 6 Newton. Again we getting minus 1 Newton. That means the net resultant force acting in this object is 1 Newton. So 1 Newton force act ಆಗ್ತಿದೆ. Minus indicates what? The direction towards the negative x-axis. So ಈ ಕಡೆಯಿಂದ force ಜಾಸ್ತಿ ಆಗ್ತಿರೋದ್ರಿಂದ object ಯಾವ ಕಡೆ ಮೂವ್ ಆಗುತ್ತೆ? Towards the left side, right? So if here we are applying some 7 Newton, 7 minus 6, again we are getting 1 Newton. Here we are getting the positive value. That means the object is moving in the positive direction. So finally the object is moving, right? So object move ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಏನು, we are not getting the value that is equals to 0, right? So minus 1 is not equals to 0. So in this case also the object is not at equilibrium. So equilibrium ಅಲ್ಲಿ ಇರಬೇಕು ಅಂದ್ರೆ ನಮಗೆ ಕಂಡೀಷನ್ ಏನು ಇರಬೇಕು, the net force acting on the object is 0, right? So here I am acting the two forces F1 and F2, right? So two forces cases ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ only we are discussing two forces, right? So net force externally applying the two forces F1 plus F2, that is equals to 0, right? So from this we can write force F1, that is equals to minus F2, right? So the object equilibrium ಅಲ್ಲಿ ಇರಬೇಕು ಅಂದ್ರೆ F1 must be equals to minus F2. That means the magnitude of the force F1 and F2 remains same. That is modulus of F1 is equal to modulus of F2. That means F1 ಗೆ ನಾವು 5 Newton ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ರೆ F2 ಗೂ ಕೂಡ ನಾವು ಎಷ್ಟು ಅಪ್ಲೈ ಮಾಡಬೇಕು, same 5 Newton, right? But here minus indicates what? It indicates the direction. So F1 positive x-axis ಅಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡ್ತಿದ್ರೆ F2 negative. That means opposite direction, right? So two forces ನಾವು ಆಕ್ಟ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಈ particles equilibrium ಅಲ್ಲಿ ಇರಬೇಕು ಅಂದ್ರೆ so two forces must be have equal magnitude. So equal magnitude, again 5 minus 5 we getting 0. So hence the object is at equilibrium, right? So that force must be opposite direction. So ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ನಾವು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಿದ್ರೆ ಇನ್ನೊಂದು ಫೋರ್ಸ್ ಅದಕ್ಕೆ ಆಪೋಸಿಟ್ ಆಗಿ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಮಾತ್ರ ನಮ್ಗೆ ಏನಿರುತ್ತೆ ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ ಅಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ. ಸೊ ಇದನ್ನ ನಾವು ಪುಷ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಈ ಕಡೆಯಿಂದ ನಾವು ಪುಷ್ ಮಾಡ್ತಿರೋದು, ಈ ಕಡೆಯಿಂದ ಪುಷ್ ಮಾಡ್ತಿರೋದು, ರೈಟ್. ಸೊ ಸೇಮ್ ವೈಸ್ pull, right. So this one we taken as F1. So F1 ಗೆ ಸೇಮ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಇಸ್ ಬರುತ್ತೆ. ಸೊ ಎಷ್ಟು ಲೆಂತ್ ಇರುತ್ತೋ ಇಲ್ಲಿ ಕೂಡ ಸೇಮ್ ಲೆಂತ್ ಇರುತ್ತೆ, ರೈಟ್. So but direction opposite, so this is towards positive x axis means it must be negative x axis, that is F2. Either push or pull, the forces having the same magnitude but applied in the opposite direction, right. So now ಯಾವುದಾದರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ನ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ಇಡಬೇಕು ಅಂದ್ರೆ by using the two forces, then the two forces must have the equal magnitude but applied in the opposite direction. So ನಾವು ಎರಡನ್ನು ಪ್ರೆಸ್ ಮಾಡಬಹುದು ಅಥವಾ ಎರಡನ್ನು pull ಮಾಡಬಹುದು, right. So this is the case when the object is at equilibrium by using the two forces. The condition is F1 is equals to minus F2. So ಇದು ನಿಮಗೆ ನೆನಪಿರಬೇಕು, right. So this is the case when two forces is acting on any particle or any object, right. So now vectors ಏನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ, so in each and every vector concept ಬಂದಾಗಲೂ ಕೂಡ ನಾವು ಮ್ಯಾಥಮೆಟಿಕಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕಂದ್ರೆ ವೆಕ್ಟರ್ಸ್ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. So next, in the second case, so mechanics ಅಂತ ಬಂದ್ರೆ ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್, ಫೋರ್ಸ್ ಮತ್ತೆ ಲಾಸ್ ಆಫ್ ಮೋಷನ್ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್, ರೈಟ್. ಸೊ ಸೆಕೆಂಡ್ ಕೇಸ್, three forces which is acting on any particle or object to keep that object is in equilibrium, right. So ಯಾವುದೋ ಒಂದು three forces ಇದೆ ನಮಗೆ. ಸೊ ಆ three forces ಯಾವ ತರ ಆಕ್ಟ್ ಆದ್ರೆ ನಮಗೆ object equilibrium ಅಲ್ಲಿ ಇರುತ್ತೆ, right. So considering the force F1, F2 and F3, right. So these three are the forces which is acting on this object. So as force means it has the magnitude and direction. So ನಾವು ಇಲ್ಬೇಕಲ್ಲಿ ಫೋರ್ಸ್ ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಆಬ್ಜೆಕ್ಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ಇರಲ್ಲ, ಇನ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಮಾತ್ರ ಆಬ್ಜೆಕ್ಟ್ ಏನಲ್ಲಿ ಇರುತ್ತೆ ನಮಗೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ಇರುತ್ತೆ, ರೈಟ್. So considering the case, these forces taken F1, that is pulling. So ಈ ಆಬ್ಜೆಕ್ಟ್ ನ pull ಮಾಡ್ತಾ ಇದೀವಿ, that means pull ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ pull is nothing but a force, right. Applying the force F1 along the horizontal direction, right. So this is one force, and the another force which is acting F2 making some angle with the F1. So ಈ direction ಅಲ್ಲಿ ಇನ್ನೊಂದು force act ಆಗ್ತಿದೆ. So here we are applying the two forces, that means we are pulling the two forces, right. So ಎರಡು force act ಮಾಡ್ತಾ ಇದೆ. To balance this one or to keep this object in stable or equilibrium, we need to apply the third force. So third force ನಾವು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವಿ, ಇದ್ರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಎಷ್ಟಿರಬೇಕು, ಜೊತೆಗೆ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಈ ಆಬ್ಜೆಕ್ಟ್ ನಮಗೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ಇರುತ್ತೆ. So that we need to find, right. So by taking initially two, ನೀವು ಈ three vectors ಅಲ್ಲಿ ಯಾವುದನ್ನು ಬೇಕಾದರೂ ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. So I am considering F1 and F2 acting with two different directions, right. So now again from the parallelogram law of vector addition, so force is a vector, two vectors making an angle with each other and two vectors representing the two adjacent sides of a parallelogram, then the resultant will give the diagonal of the parallelogram, right. So now completing the parallelogram, right. So here we get the diagonal. So this gives what, the resultant of force 1 and 2. So F12 represents the resultant of the two forces F1 and F2, right. So now the third force which we are applied on this object in such a way that that force is equals and opposite to the direction of the resultant force between the two forces, right. ಸೊ ನಾವು ಈ F3 ಅನ್ನೋ ಫೋರ್ಸ್ ನ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವಿ. ಅಪ್ಲೈ ದಟ್ ಮೀನ್ಸ್ ಇಲ್ಲಿ ಎರಡು ಫೋರ್ಸ್ ಪುಲ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಥರ್ಡ್ ಫೋರ್ಸ್ ಕೂಡ ನಾವು ಪುಲ್ ಮಾಡಲೇಬೇಕು, ರೈಟ್? ಸೊ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಪುಲ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ದಟ್ ಈಸ್ ದ ಡೈರೆಕ್ಷನ್ ವಿಚ್ ಇಸ್ ಆಪೋಸಿಟ್ ಟು ದಟ್ ಆಫ್ ದ ರಿಸಲ್ಟೆಂಟ್. ಸೊ ಇದು ಆಪೋಸಿಟ್ ಮೀನ್ಸ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್, right? So which having the same magnitude. So this gives what? The force F3, right? So ಇದನ್ನು ಕೂಡ dotted lines ಅಲ್ಲಿ ಬರ್ಕೊಂಡ್ರೆ. So now this object is at equilibrium, right? So F1, F2 and F3, right? So that is F1 plus F2 plus F3, that is equals to 0. So first we simplified the two vectors, addition of two vectors F1 and F2. We find the resultant by the method of parallelogram law of vector addition. We get the resultant. So the third force, we are acting on this object in such a way that the force which is opposite to that of the resultant, right? So ನಮಗೆ F1 ಮತ್ತೆ F2 ದಲ್ಲಿ resultant ಬಂದಿದೆ, that we taken as F12, right? So this is in this direction. The F3 we are acting, so this F3 is equals to that of minus F12, right? So opposite direction is the negative vector. So of course ನಾವು ಏನು ಕನ್ಸಿಡರ್ ಮಾಡಿದೀವಿ F3. So substituting F3, so F3 value is minus F12. So here F12 F12 get cancelled, we get the resultant 0. So sum of three vectors is 0, that means the object is at equilibrium, right? So ಇಲ್ಲಿ ಕೂಡ ನಮಗೆ parallelogram law of vector addition ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ನೀವು ಯಾವುದನ್ನು ಬೇಕಿದ್ರು ಕನ್ಸಿಡರ್ ಮಾಡಿ. ಫಸ್ಟ್ ಇನಿಷಿಯಲಿ we consider these two means, so ಅದನ್ನು ಕೂಡ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ನೋಡೋಣ, right? Same object. So initially I am applying the force F1 along horizontal and some F3 force in this direction. Again by completing the parallelogram, right? This gives what parallelogram, and the diagonal gives the resultant of these two forces. So these two forces are F13 forces, right? So the third force which is acting opposite to that, so this gives what? F2, that is equals to minus F13. So ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಆಗ್ತಿದೆ ನಮಗೆ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಿದೆ, right? So the three forces are F1, F2 and F3. So ನೀವು ಯಾವುದನ್ನು ಬೇಕಿದ್ರು ಕನ್ಸಿಡರ್ ಮಾಡಿ, right? So next, these three forces are represented by the three sides of a triangle which are taken in an order, right? So ಈ ಫೋರ್ಸ್ ನ ನಾವು ಯಾವ ತರ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಂತಿದೀವಿ ಅಂದ್ರೆ it represents the three sides of a triangle which are taken in an order, right? So first writing the force F1 as is, so now forces represent ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ parallel ಆಗಿ ಇನ್ನೊಂದು ಫೋರ್ಸ್ ನ ನಾವು ಬರೀತಾ ಇದೀವಿ. So F1 I am written here. So same wise F2, right? So F2, this is what F2, and the third force is in this direction, right? So that is in this direction, right? So now all the three forces represents the three sides of a triangle taken in an order, right? So if you name this one A, B, C, right? So the F1 force is acting from A to B, F2 is acting from B to C, and F3 is acting from C to A. So in a cyclic wise ಅಲ್ಲಿ ನಾವು represent ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ. ಯಾವುದು ನಾವು three forces ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ನ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ಇಡಬೇಕು ಅಂದ್ರೆ all the three forces should represent the three sides of a triangle which are taken in an order, in the same order or in an order, right? So ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ನೆನಪಲ್ಲಿ ಇರಬೇಕಾಗುತ್ತೆ. ಸೊ ಯಾವ ತರ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ತೀವಿ ಅನ್ನೋದು ಗೊತ್ತಿರಬೇಕು, ಮತ್ತೆ ಯಾವ ತರ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಂತೀವಿ, ಇದು ಗ್ರಾಫಿಕಲಿ ರೆಪ್ರೆಸೆಂಟೇಷನ್. So this indicates what? The value that is minus 11 Newton, right? So very important geographical representation. So this we call as mathematical relation. Right? So this is when the three forces which are acting on any object, right? So next, if so, ಇಲ್ಲಿ three forces ಆಯ್ತು. Next, ಈ ಸಣ್ಣ ಪುಟ್ಟ ರಿಲೇಷನ್ಸ್ ಇವೆಲ್ಲ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳೋದಿಲ್ಲ, ಬಟ್ ಕಾಂಪಿಟೇಟಿವ್ ಗೆ ತುಂಬಾ ಮ್ಯಾಟರ್ಸ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ನೆಕ್ಸ್ಟ್ ಥರ್ಡ್ ಕೇಸಸ್, ಫೋರ್ ಫೋರ್ಸಸ್. So four forces which are acting on any object to keep that object in equilibrium, right? So the ಯಾವ directional ಬೇಕಿದ್ರು ನೀವು ತಗೊಂಡು simplify ಮಾಡಬಹುದು. So again the final relation is F1 plus F2 plus F3 plus F4, that is equals to 0, right? So in this, if the force F1 is acting in this direction, the same equal and opposite force is acting opposite direction. So F1 is equals to minus F2. So same wise, one force will be acting in this direction, F3. So opposite to that of F3 is F4, right? So now all these four forces which represents, so same magnitude ittu andre it represents in the square form. So variable magnitude ittu andre it represents in the rectangle form. So for example, F1 force having some 4 Newton, right? So automatically F2 is also equals to 4 Newton. So F3 it adds some 6 Newton, then F4 will act as the same magnitude 6 Newton, right? So that means 6 then 4, it represented by the rectangle. Or again here F3 is acting 4 Newton, means F4 is also acting with 4 Newton, right? So representation is F1, so keeping asterisk, parallel. Next vertical component, that is F4, right? So next F2, again F3. So it represents the four sides of a square or rectangle. So magnitude same ittu andre square irutte, magnitude vary ittu andre rectangle irutte, right? So again the condition F1 plus F2 plus F3 plus F4 is equals to 0. So if many number of forces are acting, right? Case 4, that means F1, F2, F3 and so on up to n number of forces which are acting on this object. So ಯಾವುದೋ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಮೇಲೆ ತುಂಬಾ ಕಡೆಯಿಂದ forces, right? So ಈ ಕಡೆಯಿಂದನೂ ಹಿಡಿತಿದ್ದಾರೆ, ಈ ಕಡೆಯಿಂದ ಹಿಡಿತಿದ್ದಾರೆ. That means pulling this object in all the direction. That means we have more than 4 forces which are acting on this object. Again the relation is same, right? So F1 plus F2 plus F3 plus and so on up to Fn, that is equals to 0. If n number of forces which are acting on an object to keep that object in equilibrium, right? So representation of the all the four forces, so ಇಲ್ಲಿ square or rectangle ಆಗಲಿ, ಇಲ್ಲಿ triangle ಆಗಲಿ. So here more than 4 sides ಇತ್ತು ಅಂದ್ರೆ ಅದನ್ನ ಏನು ಕರೀತೀವಿ? Polygon, right? So polygon way ಅಲ್ಲಿ ಅದನ್ನ represent ಮಾಡ್ತೀವಿ. F1, F2, F3, F4 and so on. So this is Fn. So 5 force acting means pentagon, 6 forces acting means hexagon, and more than 6 we call that one as polygon, right? So representation, graphical representation, we represent that force in the polygon shape, right? So 3 forces triangle, 4 forces square or rectangle. So equal and opposite magnitude, right? So mathematical formula plus graphical representation. So this is about the equilibrium of a particle, right? So here all the forces which are applied on this object is concurrent coplanar forces. So we define this in vectors. So concurrent means all the forces which are acting from a single point, right? So e point in the force act ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಎಲ್ಲಾ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲೂ ಕೂಡ same point in the force act ಆಗ್ತಿದೆ, right? So on that particle is concurrent. Coplanar means all the forces which are in the same plane. So ಇಲ್ಲಿ forces F1 which is acting in xy plane means F4 is also which is acting in xy plane. F3 is also acting in xy plane, F2 is acting in XY plane. So ಎಲ್ಲ forces ಕೂಡ same plane ಅಲ್ಲಿ act ಆಗ್ತಿರ್ಬೇಕು. So ಅದಕ್ಕೋಸ್ಕರನೇ equilibrium of particle we studied in concurrent coplanar forces, right? So all these three lies in a same plane, right? So plane means which having the two coordinate system x y y z or z x. So ಯಾವುದಾದ್ರು ಎರಡು coordinate system use ಮಾಡ್ಕೊಂಡು ಡಿಸ್ಕಸ್ ಮಾಡೋದನ್ನ ನಾವು plane ಅಂತೀವಿ, right? So the same force which is acting on a particle in three dimension or it is in a space. So ಇದು space ಅಲ್ಲಿ ಯಾವುದಾದ್ರು object equilibrium ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ then the force F1x plus F1y plus F1z that is equals to 0 and F1 that is 2x plus F2y plus F2z that is equals to 0, then F3x plus F3y plus F3z that is equals to 0. That means F1x, F2x, F3x, all these three represents the dimension, that is coordinates along x-axis. So spatially force act ಆಗ್ತಾ ಇರೋದು, it represents the magnitudes of the forces which are acting in the space. So spatially force act ಆಗ್ತಿದೆ ಅಂದ್ರೆ F is equals to xi cap plus yj cap plus zk cap. So three forces act ಆಗ್ತಿದೆ ಈ particle ಮೇಲೆ, that is in the space means 1x, 2x, 3x. That must be equals to 0, right? So this is, so spatially now study ಮಾಡ್ತಾ ಇಲ್ಲ, only in two dimension, right? That is in plane. So plane ಅಲ್ಲಿ maximum we are going to discuss in three forces, two forces and maximum four forces which are acting, right? So this is about the equilibrium of a particle, right? So ನಮಗೆ ಸಿಸ್ಟಮ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಅನ್ನೋ ಚಾಪ್ಟರ್ ಬರುತ್ತೆ. ಸೊ ಆ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಇದನ್ನ ಇನ್ ಡೀಟೇಲ್ ಆಗಿ ಇದ್ರ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. ಸೊ ಅಲ್ಲಿವರೆಗೂ ಜಸ್ಟ್ ಫಾರ್ ಸಾಲ್ವಿಂಗ್ ದ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬೇಸ್ಡ್ ಆನ್ ಫೋರ್ಸಸ್. ಸೊ ಫೋರ್ಸಸ್ ಮೇಲೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಿರೋದ್ರಿಂದ ಇಷ್ಟು. ಸೊ ಸಿಸ್ಟಮ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಅಂದ್ರೆ ಪೂರ್ತಿ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲೇನೆ ಸ್ಟಡಿ ಮಾಡೋದು ಆಬ್ಜೆಕ್ಟ್ಸ್. ಸೊ ಅಲ್ಲಿ ಇನ್ ಡೆಪ್ತ್ ಆಗಿ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. ಸೊ ಎಲ್ಲ ಚಾಪ್ಟರ್ಲು ಎಲ್ಲ ಟಾಪಿಕ್ಸ್ ಯಾವುದಾದ್ರು ಒಂದು ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ರಿಲೇಟ್ ಆಗೇ ಆಗುತ್ತೆ. ಸೊ ಎಲ್ಲ ಟಾಪಿಕ್ಸ್ ಬಗ್ಗೆನೂ ಐಡಿಯಾ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ನೆಕ್ಸ್ಟ್ some common forces used in mechanics. So now study ಮಾಡ್ತಿರೋದು mechanics, that is classical mechanics. So in this chapter we are going to discuss few basic forces. That means we are going to study in mechanics. That means ಯಾವುದಾದ್ರು ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಮೂವ್ ಆಗ್ತದೆ, ಯಾವ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ, right? So ಯಾವ್ದ್ರಿಂದ ಆಕ್ಟ್ ಆಗ್ತದೆ ಅದನ್ನೆಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡೋದು forces. So in the previous only we discussed there are two types of forces. One is non contact force and the another one is contact force. So non contact force means ಯಾವುದಾದ್ರು ಎರಡು ಆಬ್ಜೆಕ್ಟ್ ಬಿಟ್ವೀನ್ ಫೋರ್ಸ್ ಎಸ್ಟಾಬ್ಲಿಷ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಯಾವುದೇ ತರದ್ದು ಕಾಂಟ್ಯಾಕ್ಟ್ ಇರಲ್ಲ ಎರಡು ಆಬ್ಜೆಕ್ಟ್ಸ್ ಗೆ. ಸೊ ದಟ್ ಟೈಪ್ ಆಫ್ ಫೋರ್ಸ್ ವಿ ಕಾಲ್ ಆಸ್ ನಾನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್, ರೈಟ್? ಸೊ ದ ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ದ ನಾನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಹಿಯರ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡೀಸ್. ಸೊ ನಮಗೆ ಎರಡು ಬರುತ್ತೆ, ಒನ್ ಇಸ್ ಗ್ರಾವಿಟೇಷನಲ್ ಫೋರ್ಸ್, ಅನದರ್ ಇಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ ಅಂಡ್ ಆಲ್ಸೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೋರ್ಸ್. ಸೊ ಹಿಯರ್ ಇನ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡಿಸ್ಕಸ್ ಅಬೌಟ್ gravitational force. So one contact force here we are going to discuss, so that is the gravitational force. So every object which attracts by the gravity of the earth, so that force we call as the gravitational force, and it is also a vector, so its direction is always towards the center of the earth. That means that arrow mark should be in the downward direction, right? So gravitational force act ಆಗ್ತಿದೆ ಯಾವುದಾದ್ರು ಆಬ್ಜೆಕ್ಟ್ ಮೇಲೆ ಅಂದ್ರೆ ಅದರ ಆಬ್ಜೆಕ್ಟ್ ಫೋರ್ಸ್ ಯಾವ ಕಡೆಗೆ ಇರುತ್ತೆ, it is always towards the center of the earth. For example, if I consider any object having some mass. So this object experiences the gravitational force. That means it is moving towards the center of the earth with an acceleration that is g. So g is the acceleration due to gravity, right? So here the force is acting, so that force is equals to m into g. So now study Newton second law. Mass is there, it will moving means it has some acceleration. So the force acting is F is equals to ma, right? So mass into acceleration of the body. So now ಎಷ್ಟು force apply ಮಾಡ್ತೀವೋ ಅಷ್ಟು acceleration ಅಲ್ಲಿ move ಆಗುತ್ತೆ. So same wise this acceleration is due to the acceleration due to gravity, that is from the gravitational force. So that's why F is equals to mg, and also we call that one as weight of the object, right? So almost mg we represent that one with weight of an object is equals to mass into acceleration due to gravity, right? So it is a vector and its direction is always downwards. So ಎಲ್ಲೆಲ್ಲಿ ನಮಗೆ weight ಅಂತ represent ಮಾಡ್ಕೊಂತೀವೋ ಅಲ್ಲೆಲ್ಲ downward direction ಅಲ್ಲೇ ನಾವು represent ಮಾಡ್ಕೋಬೇಕು, right? So mechanically only we are discussing about the gravitational force, right? So next, contact force. So main we are going to discuss the forces. Those forces are the contact force, right? So what are contact force? So any object experiences a force due to contact with other objects, right? So any object which is experiencing a force due to contact with the other objects. So ಯಾವುದಾದರೂ ಒಂದು object force na experience ಮಾಡ್ತಿದೆ. ಯಾವಾಗ experience ಮಾಡುತ್ತೆ? when it is in contact with the other objects. So ಬೇರೆ object ಜೊತೆ ಅದು force na experience ಮಾಡೋದಕ್ಕೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ? contact force, right? So the example is book is resting on the table. So ಯಾವುದಾದರೂ ಒಂದು book table ಮೇಲೆ ಇತ್ತು ಅಂದ್ರೆ, so book is one object and table is the another object. So these two which are in contact, there is a force, so that force we call as the contact force. So ಯಾವುದಾದರೂ ಎರಡು object between force exist ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಅಂತ force ನ ನಾವೇನಂತ ಕರಿತೀವಿ? contact force. That means those two objects must be in contact with one another. That means book is in contact with the table, so there exists a force, so that type of force is called the contact force. So here I mentioned contact with the other objects. So these objects either it may be solids or it may be fluids. So fluid means again it may be gas or it may be liquid. So solids gases ಜೊತೆ ನಾವು ಕಾಂಟ್ಯಾಕ್ಟ್ ಇರಬಹುದು, solids liquids ಜೊತೆ ನಾವು ಕಾಂಟ್ಯಾಕ್ಟ್ ಇರಬಹುದು, ಅಥವಾ gases liquids ಜೊತೆ ಕಾಂಟ್ಯಾಕ್ಟ್ ಇರಬಹುದು. So here we are discussing about the mechanics. So main we are going to discuss the solids which in contact with the gases. So here there exists a force, that force we call as air resistance. So gases jothe contact agittu andre air jothe, gas nothing but we directly taken that one as air, right? So when solids is in contact with the air, there exists a force, so that force we call as air resistance, right? The same way the solids which are in contact with the liquids, so there exists a force, so that force we call as buoyancy force or buoyant, right? So when solids with the liquids, solids contact with the liquids, there exists a force, so that force we call as buoyancy force or buoyant force, right? So one more that is arises in the liquid, that is viscosity. So this is also one force, right? So mainly we are going to discuss about the solids. So keeping aside solids, when two solids are in contact, we are getting the force, so that force we call as the contact force, right? So best example is book is resting on the table, or any object which are placed or hanging with the threads or connected with the rods. So ಯಾವುದಾದ್ರೂ ಎರಡು object ತಗೊಂಡು ಅದ್ರ ಮೇಲೆ force ಕಾಂಟ್ಯಾಕ್ಟ್ ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ ಅಲ್ಲಿ ಫೋರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ದಟ್ ಫೋರ್ಸ್ ವಿ ಕಾಲ್ ಆಸ್ ದ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್. ಸೊ ಅಗೈನ್ considering here one object, so that is object A. So this object is in contact with the another object, that is object B, right? So object A is in contact with the object B. So contact surface is only this much, right? So ಎಲ್ಲಿಂದ ಎಲ್ಲಿವರೆಗೂ ಇದೆ A ಮತ್ತೆ B ಜೊತೆಗೆ ಕಾಂಟ್ಯಾಕ್ಟ್ only. So ಅದಕ್ಕೆ ನೇಮಿಂಗ್ ಕೊಡೋದಾದ್ರೆ x y. xy is the contact surface between the object A and object B, right? So here in contact force, so force is nothing but a vector. So this force we can resolve into two components. I already ಹೇಳಿದೆ vector study ಮಾಡಬೇಕಾದ್ರೆ ಅದರ applications ತುಂಬಾ ಇದೆ, right? So if we having any force, so this force we can resolve into two components, that is one is along horizontal and another one is along vertical. That means horizontal component and vertical component, right? So here xy existed contact force. So xy is the reason which is contact between the two objects A and B. So in this region there is a force is existing, so that force we call as a contact force. So this force we can resolve into two components, one is along horizontal and along the vertical. Vertical means perpendicular, horizontal means parallel, right? So this is the surface xy, right? So I will write here. So this is the surface xy. So in this surface there is a force. So that force is the contact force. So the component of the contact force, that is either we can take vertical or we can take horizontal. So first we will discuss about the vertical component, right? So the component of a contact force which is perpendicular to the surface, right? So perpendicular means 90 degrees. So this is the contact force, right? So that contact force we call as normal or reaction. We call normal reaction, right? So that is the first one is the component of contact force which is perpendicular के another name ना नावेनता करीतीवी normal. So ये भी बोलते हैं always we use normal instead of perpendicular, right? So the component of contact force which is perpendicular to the surface, then that force we call as normal or reaction. So wherever if we use normal force, so that normal force is always perpendicular to the surface of contact. So ಇಲ್ಲಿ xy ಇರೋದನ್ನ ನಾನು ಇಲ್ಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಪರ್ಪಸ್ ಇಲ್ಲಿ ಬರ್ದಿದ್ದೀವಿ, ಬಟ್ ಆಲ್ವೇಸ್ ದ ಫೋರ್ಸ್ ಇಸ್ ಆಕ್ಟಿಂಗ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್. ಸೊ ನಾವು ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡೋದ್ರಿಂದ ಇನ್ಸೈಡ್ ಅಂದ್ರೆ ನಮಗೆ ಐಡಿಯಾ ಸಿಗೋದಿಲ್ಲ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಏನ್ ಮಾಡ್ತೀವಿ, ಮೇಲ್ಗಡೆ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. ಐದರ್ the force which is acting A on B, it should be in the upward direction. The force which is acting on B, that is force acting on A due to B, so that should be in downward direction. So it may be in the upward direction or it may be in the downward direction. So ನಾವು ಯಾವ್ದ್ರದ್ದು ಫೋರ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದೀವೋ ಅದನ್ನ ರೆಫರೆನ್ಸ್ ಆಗಿ ಇಟ್ಕೊಂಡು ನಾವು ಅಪ್ವರ್ಡ್ ಆದ್ರೂ ತಗೋಬಹುದು ಅಥವಾ ಡೌನ್ವರ್ಡ್ ಆದ್ರೂ ತಗೋಬಹುದು, ರೈಟ್? ಸೊ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಮೀನ್ಸ್ ಬೋತ್ ದ ಕೇಸಸ್. ಸೊ ಈ ಎರಡು ಕೇಸಸ್ ಅನ್ನು ನಾವು ಏನಂತ ಕರೀತಿದೀವಿ, perpendicular, right? So upward ಆದ್ರೂ ಇರಬಹುದು, downward ಆದ್ರೂ ಇರಬಹುದು, that is which is always perpendicular. So ಈ ಆಬ್ಜೆಕ್ಟ್ ಮೇಲೆ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ always it should be perpendicular and maximum case we will take in the upward direction, right? So that force we call as normal or reaction. So this is the one force we are going to discuss. So that is in the contact force, right? So this is one component. So remaining one more is there, that is along the horizontal, right? The component of contact force which is parallel to the surface. The component of the contact force which is parallel to the surface. So xy is a surface. So parallel means either in this direction or in this direction. So xy ಗೆ parallel ಆಗಿ ಒಂದು ಫೋರ್ಸ್ ಇರುತ್ತೆ. So that force which is parallel. ನಾವು ಎಲ್ಲಿ ಬೇಕಾದ್ರೂ ತಗೋಬಹುದು ಆ ಫೋರ್ಸ್ ನ, right? So parallel to this surface, that is in between A and B. ಈ ಎರಡು ಆಬ್ಜೆಕ್ಟ್ ಮಿಡ್ಲ್ ಅಲ್ಲೇ ತಗೋಬೇಕು. ಎಲ್ಲಿ ಬೇಕಂದ್ರೆ ಎಲ್ಲಿ ಬೇಕಲ್ಲಿ ತಗೊಳಂಗಿಲ್ಲ. Between the two objects, right? So that force we call as frictional force or force due to friction, or simply we call this one as friction. So idu ನಾವು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಡಿಸ್ಕಸ್ ಮಾಡೋ ಟಾಪಿಕ್, that is friction, right? ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಅಲ್ಲಿ ನಮಗೆ ಎರಡು ಕಾಂಪೋನೆಂಟ್ಸ್ ಬರುತ್ತೆ. ಒನ್ ಈಸ್ ಹಾರಿಜಾಂಟಲ್ and another one is vertical. So horizontal ಅಲ್ಲಿ act of a force na ನಾವು friction ಅಂತ ಕರಿತೀವಿ. So ಯಾವ direction? So now while discussing the concept, we will check in which direction the force is acting, that is contact force, either in the positive x axis or in the negative x axis, either in the positive y axis or in the negative y axis, right? So horizontal force is the friction and the vertical force we call that one as normal. So this normal is always perpendicular to that of the surface. So surface ಗೆ ಯಾವಾಗಲೂ perpendicular ಆಗೇ ಇರುತ್ತೆ. ಇದ್ರದ್ದು ಡೈರೆಕ್ಷನ್ ಏನಾಗೋದಿಲ್ಲ, ಚೇಂಜ್ ಆಗೋದಿಲ್ಲ. For example, so this is the object which is placed on a table. So the normal force which is always perpendicular to the surface of the object. So if this object is inclined, right? So ಇದು ಯಾವುದೋ inclined plane ಇದೆ. So inclined plane ಮೇಲೆ ನಾವು ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ನ ಪ್ಲೇಸ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ನಮಗೆ ನಾರ್ಮಲ್ ಈ ತರ ಇರೋದಿಲ್ಲ, right? So upward direction ಅಂದ್ರೆ surface ಗೆ perpendicular ಆಗಿರಬೇಕು. That means the direction should be perpendicular to this direction, that is surface ಗೆ 90 ಡಿಗ್ರಿ ಆಗಿ ತಗೊಳ್ಳೋದನ್ನ ನಾವು ನಾರ್ಮಲ್ ಅಂತ ಕರಿತೀವಿ, right? So ಇಲ್ಲಿ ನಮಗೆ ಪ್ಯಾರಲಲ್ ಇರೋದ್ರಿಂದ ಈ ತರ perpendicular ಇದೆ. So ಈ ಪ್ಲೇನ್ ನ ನಾವು ಇನ್ಕ್ಲೈನ್ ಮಾಡಿದ್ರೆ ಇದು ಕೂಡ ಏನಾಗುತ್ತೆ, ಇನ್ಕ್ಲೈನ್ ಆಗುತ್ತೆ and it is perpendicular to the surface. ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್, ಇದು ನಿಮಗೆ ನೆನಪಲ್ಲಿ ಇರಲೇಬೇಕು, right? So ನೀವು ಡೈರೆಕ್ಷನ್ ಏನಾದರೂ ಸ್ಟ್ರೈಟ್ ತಗೊಂಡ್ರೆ it goes down, right? So few more forces are there, so we will discuss in our next class, right? Thank you.